There once was a burr who lived in a field. One day, she decided to pull up her roots and move to another field. After all, she was tired of getting pricked by all of her siblings and of being stuck to her mother plant. As the day wore on, various animals came and went through the field. When Burr saw a passing deer, she seized her opportunity for a clean escape and hooked herself into his fur. "Hello, dear," she said. "If you take me to another field, I will tell you a very strange and clever story." The deer, being quite clever himself, was always interested in new stories. He agreed to the proposition and allowed the bird to rest behind his ear. And so she told him the only story she knew by heart. The story of the rise of the Sporophyte. "One day I will grow tall," the bird began, "just as all birds do. But that hasn't always been the case for sporophytes. My ancestors originally lived in the water. They learned that they could only come onto land when they became desiccation tolerant. And so they evolved an insult-resistant coating that protected their spores from the sun. This coating allowed them to disperse their insult-resistant spores through the air. Yet, because they still had to disperse their sperm through the water, they needed to remain close to the ground, where it was moist. They would solve this problem later. These plants soon learned how hard it was to disperse their spores in an unpredictable world. Knowing that it was a good idea to produce more spores, plant zygotes decided to undergo mitosis following fertilization in order to increase the size of their spore-producing body. Thus, the sporophyte began its rise. However, my sporophyte ancestors were torn. On one hand, they wanted to grow tall to disperse their spores, but on the other hand, their gamete-producing mothers wanted to remain close to the moist ground. For instance, 3 of my ancestors, liverwort, hornwort, and moss, each had aspirations to be big and tall. But try as they might, none of them as sporophytes grew freely. Each was still chained and dependent on his mother gametophyte. Ambitious young hornwort did manage to become a long-lived sporophyte, but he was still limited to places where a plant with roots would not fare better. Many years later, a wonderful innovation emerged among a group of plants known as the wise tracheophytes. They had water-conducting tubes or tracheary elements with lignified secondary walls, which allowed for them to not only colonize on land, but also to reach for the stars. These vascular elements were known as the xylem and the phloem. The xylem brings water to the leaves, while the phloem transports sugars produced in the leaves to the rest of the plant. The lycophytes also evolved roots. These vascular tissues allowed my ancestors to transport water from their roots to the top of their stems. My ancestors could thus become taller and taller. Realizing that my bryophyte relatives would always remain small, my tracheophyte ancestors decided to take over. The first group of tracheophytes, the lycophytes, were very different from the bryophytes. Whereas the sporophytes of bryophytes did not branch, lycophyte sporophytes did, often with multiple sporangia. Also, the lycophytes developed roots, which allowed them to take in even more water. Finally, they realized it would be beneficial to produce separate microspores and megaspores to prevent inbreeding. These tracheophytes were consequently able to grow strong. Yet, sporophytes are never satisfied. They always want to keep growing to get taller and taller. It wasn't long before the realization was reached that in order to keep growing upwards, something had to be done about stem girth and strength. Here, secondary growth played a supporting role, replacing not only worn-out vasculature, but ensuring there would be strength along with transport capacity. Yet, vasculature and secondary growth were not enough. The lycopods, and even new groups of tracheophytes, such as the ferns, were still limited by their dependence of the fertilization processes on water. What could possibly help the sporophytes break free from such dependence? The answer was the development of the seed, and the ability of the microgametophytes to fly through the air directly to the megagametophyte, who was tucked away safely within her megasporangium home, never to be ever seen. The development of the seed was of great benefit in the gymnosperms and angiosperms. The seed aided in sporophyte dispersal by allowing for the young sporophyte embryo to enter into dormancy during tough conditions. The angiosperms saw the emergence of all sorts of fruits, which is where you and I come in. Fruits attract helpful animals, thereby aiding in further sporophyte dispersal. The bird paused as the deer came to a stop in the middle of a new field. "Thank you for your help," she shouted as she leapt from his fur into the rich soil. The deer in turn thanked her for the story, for it had been one of the most amazing tales he had ever heard. The end.